We're in a field of David Armstrong's here today, part of our Net Zero project. The Net Zero project is a 3-year study into all the different elements of growing a crop, right the way from the soil, the biology, the nutrition, the diesel consumption, the cold storage, everything that goes into producing potatoes, we're looking to capture during this project. David, can you tell us a little bit about the farm? What do you grow?
Yeah, we'll grow quite a wide range of combinable crops as well as potatoes, including wheat, barley, oilseed rape, peas, beans, linseed. We hope to retain as much nitrogen as we can for the following crop. So ideally we want to take the nitrogen from the autumn to the spring without losing any to water. We think it's important to grow cover crops now, especially on the lighter soils. And so we established a cover crop of both vetch and Phacelia, and it established very well after the very dry weather earlier last summer. I think we'll be getting going just after Easter. We've had quite a very wet March, and the land's still got a little bit more drying to do, and hopefully by then it will have warmed up a little bit as well. I'm not quite sure why I grow potatoes, but I love them.
So Iain's here from the University of Lincoln to really do all of those important tests that we need to capture before we've started planting.
We have here what's called a TDR, so that's going to help us take a reading of soil moisture and at the same time soil temperature. That's going to be really important as the crop grows, because obviously the biological activity in that soil from the crop and from the microorganisms in the soil are going to be dependent on moisture and temperature. So we've got a couple of probes at the bottom here, so we just place that in the soil, take a reading. So we've got a nice patch here where we've definitely got some cover crops starting to get incorporated. And we're just going to look in the soil. So if I lift a block out like that, we can already see, look in here, the worms are in there. And hopefully they're starting to break down this cover crop and bring that organic material into the soil. There's going to be a lot of microorganisms. There's stuff we can't really see in the field with the human eye. So we've got stuff like bacteria, fungi, perhaps nematodes in that soil as well. It's a really, if you scale down with a microscope, it's a real complex system going on in the soil. Probably in that handful you're holding there's more microorganisms than there are people on the planet. So one of the processes we're looking at is how microbes can break down organic material like this cover crop, like any organic fertiliser we put on. And if we can have a healthy soil where microbes do that, then perhaps we can rely less on synthetic fertiliser inputs. We're taking baseline nitrogen samples across the whole field, the whole trial field, so we know exactly what's in the soil now, and then we can map that throughout the trial, how much the plants use, how much stays in the soil. As we take the samples out, we pop them in the bag, and then they go to the laboratory for soil nitrogen analysis. We're going all the way to 90 centimetres in this field, but we separate that into top 30, middle 30, bottom 30 centimetres. What we want to do is look at where the nitrogen is in the soil, particularly as we go into planting. We want to make sure that nitrogen's in the soil where we want it and it's not leached down into the subsoil or perhaps into our groundwater. If we look at our cycles rather than applying fertilisers, we look at how the role of biology and how we can input and enhance that, it's going to make us much more efficient in our fertiliser use. So we get better, more productive crops, but also we're not having some of those negative effects on the environment. The University of Lincoln's looking at the role of soils and biology in the process of potato production and how we can enhance that process perhaps with reduced inputs or with other ways of managing the soil to improve our soils but also produce a healthy crop.